Hello again, it's Mr. Pete, your YouTube shop teacher, and boy have I got a lot of videos coming up. I still haven't shown the video on this Beverly shear restoration. There will be a video eventually on this 4-inch Wilton bullet vise, and really the purpose of today's video is a follow-up on that recent auction video that I did to update on some of the things that I bought there. And a lot of those things that I'm going to say revolve around comments and corrections and information that people gave me. So what is the video I'm talking about, in case this is a couple years back? Well, I went to an auction last week, and then more recently than that, I bought, or I was given, a huge stash of tools. So watch for that video too. I think I'll give you a little information on that right now in regards to the title of those two videos. So take a look at that, and then we'll start on this video. So this is the title of the auction that I am following up on. Now there are two parts to this. Be sure and watch it. And this is my most recent video regarding my hoard of tools. It's also two parts. You will love this. Now remember, this is a follow-up video. So the first thing I'm going to do is to see if my diagnosis was correct on this old Craftsman compressor that I bought, and you will recall that it smoked out. Let me show you that clip real quickly for a laugh. Uh-oh, she's blowing smoke. Well, what I had deduced was wrong with this is that probably the starting windings are burnt out, and that was caused by the centrifugal starting switch sticking in the on position. Now somebody said, no, it's the capacitor. Well, you can see that this is not a capacitor start motor. I don't see a capacitor anywhere. So let me go ahead and take the end bell off so we can examine the windings and see if I was correct. I do not intend to put this nightmare back together, so it's a one-way trip, and then it's going to the scrapyard. Well, first of all, let's take a gander at the windings here. Now, these are the running windings, and you can see that they are not burnt. So the running winding is not the problem. They would be very charred if they were burned. Now, the starting windings are farther in, and we have to take it apart to examine those. I have, of course, taken off the plastic covers. I think I did that in the last video. And somebody said, well, make sure that there's no interference or mouse nests or anything else in there, but there's nothing rubbing on the fan. You can see the connecting rod right from here. It's kind of interesting. Okay, I'll take these motor bolts off. There's 4 of them holding the end bells on. I won't show all of that because it's kind of awkward to get on these back heads, but you can see that there's 4 long bolts that hold the motor together, pretty much like every other small motor you've seen. Okay, all 4 draw bolts are together. Let's see if the end bell will come off. Fortunately, I don't care if I damage anything, so if I seem a little crude, it's because I guess I am. Alright, there is the centrifugal switch. I'm going to cut the wires simply so that I can look at the points or the contacts in there. And I was wrong looking here at the centrifugal switch. There's the contacts right there, and they are not fused together. So I was wrong on that. Well, I can't see anything at all by looking into the end of the motor because of this shield, so I hope that the entire stator here, motor body, will pull off. It seems to be a little corroded here, but it's coming. Well, it's never easy, is it? Never seen a motor held on like this. So we got to move it forward before we can move it backwards. And now I've got interference here with something. There. Finally, she comes apart. And my diagnosis was correct. I'll show you. What I told you about the centrifugal switch may have been wrong as far as is it open or closed when it engages the starting windings. But anyway, that aside, there are two sets of windings in any small motor, split phase type motor or capacitor motor. The large diameter wires, and there's 4 fields coils here, are in nice shape, but if I examine the starting windings, which are the smaller windings here, the inside windings that I'm touching, you can see that the varnish is burned off, and you see how easily it separates, how easily the wires separate. So that's all charred, and that was the cause of failure, was that the starting windings, which are meant to be used only intermittently until the motor starts, and then they're disconnected, and these apparently didn't get disconnected from the circuit, and current was still going through them, and then it caused them to burn out, and hence the smoke. So that part was correct, but as far as what I said about the switch, well, it's still a failure of the switch, I'm sure. By the way, there's no mouse nests or vermin nests or anything like that in there. Let's take a look at how this compressor is built. Real cheaply, but kind of ingenious. Okay, we got a cooling fan. We've got the shaft, the motor shaft, driving the crankshaft directly. So we've got a bit of a flywheel here, rather heavy, plus the motor serves as a flywheel as well. And then it looks like it's about 2.5-inch diameter piston with an 1.25 inch stroke. And I've always been told that the real large diameter and short stroke is what makes them so noisy. I'm not real sure. It's all aluminum, a bit corroded, but in good shape. The fan is plastic. And some of you are going to say, well, why don't you mount your motor here? But, you know, this is scrap. I paid 15 bucks for it, and it was fun, and I hope it was a fun part of the video. Now, you probably watched another video that I had. That was an autopsy of a Craftsman tank. Now, some of you are going to say, I know, don't ruin that tank. You can use it as a spare. You can do this. No, I'm not. 78 years old. However, I'm going to cut a hole in the bottom with the grinder. Wish I had a plasma cutter. And we'll see how much corrosion is in here. This was built in about 1990, but it may not have been used for many years. I'll come back after I cut that hole. You don't need to see that. I don't want to see it myself. I don't know why I torture myself. That was 15 minutes of absolute agony using the Horror Freight grinder because it keeps throwing the overload, you know. But anyway, other than when that happens, this is a great tool. So that's the reason I haven't thrown it out. I do have an air one, but I don't really have a compressor. Anyway, let's see what this looks like. I will be cutting myself, just so you know. Now, there was no water in here. But looking down in there, it is moist. And what in the heck is this? It looks almost like clay. So that is moist dirt and rust and so on. Let's take a look down into the bowels of this tank. I'm sure that it was never ever drained. Matter of fact, let me dump that. You can see that this is the drain, and it was totally clogged up. So even if somebody opened this, it probably wouldn't blow out unless you use a ramrod in there. So that's never been opened. But that's probably typical. I doubt very much that most people, especially suburban house husbands, would ever do that. All right, let's look in there real quickly. I don't know if we can see anything. The top side of the tank, which the flashlight is pointing on isn't bad at all. There's a chunk of that clay that fell in there after I pried this hole open. So this was worth looking at. Now I'm going to clean this piece and see how rusted it is or is not. Okay, let me scrape this off. And there wasn't any of that flaking rust on the inside like there was on that other one from a couple years ago. Yeah, it almost feels like dirt or clay. And look at how stopped up the drain cock is. Let me real quickly just brush a little bit off because I'm trying to see the extent of the corrosion. And you know what? This is kind of amazing, but I believe this tank must have been treated some way on the inside because there really is no corrosion, or, well, maybe that's a little pitting there. Possibly, but really in excellent condition. So I doubt if this would have blown up if I decided to use the tank for something else. By the way, even though I showed you a video clip one time of one of these actually blowing up, really they're not going to blow up once they get a hole. It'll be a tiny pinhole and there'll just be a very small leak that will progressively get worse and worse and worse. All right, let's move on to something else. I beat this to death, but I think it was interesting. At least it was to me. I hope it was to you. Let me get this table cleaned off now, and we'll talk about another item from that video. Let me correct myself just a little bit. As I moved the compressor tank across the shop and parked it there, it did leave a very small trail of water. So there was a little water in there, but it couldn't have been a tenth of a pint or so. It didn't gush out. It was not a problem. It was not even a mess. Now, let me correct myself on this compound. Remember, I agonized about what this was, and I had a one-track mind since this was setting on the Logan lathe, at least at one time, till the man moved it over there on that other table. And I was just insisting that it was something to do with Logan. And I even said this is the same color. I had all kinds of excuses and rationale. Couldn't have been wronger. More wrong, make that. So somebody in the comments, actually several people said, well, that's simply the compound off of a Delta wood lathe. And in fact, there was a Delta wood lathe sold at that auction. Do you remember? If you have watched that video, I think they showed it being sold. And this belonged with that. So let me show you something in a catalog. So thank you guys that put a comment in there that corrected me. This is the Delta Rockwell Industrial Power Tool catalog from 1958. And this was apparently the 12-inch Delta standard wood lathe that was sold at the auction. However, it was mounted on a wooden bench, not the fancy cast iron bench. But now on the next page are accessories for Delta wood lathes. Actually, there's 2 pages of it. Well, I guess that's for metal. But let's zoom in on this item right here. And so there it is. You can turn your wood lathe into, well, not a metalworking lathe, but a woodworking lathe with a compound, and in my mind have a lot more control over what you're turning. I never did like to use chisels. I like to use my metal lathe as a wood lathe when necessary. Let me show you the catalog description. See, it's called the compound slide rest. Read that if you want. Well, in the same auction, I bought this brand new brake rotor. I don't know what the application is, what it's supposed to fit, and doesn't matter. But it is in perfect shape. It was still in wax paper. I was just going to use it as a machine base or, you know, a counterweight on my sand molds or something like that. Not a counterweight, just a weight. And somebody said, well, use that for tramming on your milling machine. So let's go down on the Bridgeport mill and I'll show you what he meant. I'm not sure I'm going to use it, but this is what he is suggesting. Alright, now I'm down in the basement next to the Bridgeport mill and I'm going to show you how to use this brand new brake rotor as an aid to tramming. Now I'm not going to go through the full demonstration. That'll be done some other time maybe, and I've done a lot of videos on that. But before I do that, first of all, examine this rotor for nicks or wear. You got to use a new one. Don't use an old one. And make sure there's no corrosion or high spots or anything like that. And I'm going to take it over to the bench and I'm going to mic it in about 6 different places because the two faces here of the rotor have to be perfectly parallel to one another. So using an excellent Starrett 2-inch micrometer and make sure everything is clean, I'm going to mic it, and it does not matter what the reading is. It just matters that the reading be the same in all spots. So I'm just saying it's on 21, 21, 21, and I've already done it the rest of the way around, and it is perfectly parallel. It's a very nice rotor, whoever made it. Why would you do this anyway, rather than just sweeping the table? Well, maybe you wouldn't, but the fact is, as you sweep the table with an indicator, the indicator drops into the T-slots and it goes clunk-a, clunk-a all the way around, and you got to be very careful not to damage the tip. So that's the essence of this, but this is certainly optional. Make sure that your table is clean of trips and there are no high spots. You may need to take an oil stone and then take the brake rotor and wipe it off clean as well. And I've already pre-marked this to speed up this. And I've got a little Starrett indicator already mounted with an extended stem onto the spindle. And you can use any one of your holders, couldn't matter less. Although this raised hub here may cause some interference. I had to fiddle around with that and finally found a tip out of the dozen on here that was just right. And this is just perfect for tramming both from left to right and the knotting front and aft, whatever you want to call it. Depends on if you were in the Navy. And I'll bring the point down. And I will lock the quill, and I'm adjusting the table height, which you cannot see, to 0. And I'm not really going to tram, I'm just taking a check here, but as you can see, I can spin it around. Do not turn the machine on, whatever you do. And in fact, I'm a couple thousandths off. It does need to be trammed, but see how nice that works? You don't have to deal with the T-slot. So that was a good suggestion. Thank you to whoever mentioned that. And I had heard about this, but I just had never done it. But what a nice surface this is. Far smoother than my actual fairly beat up table on the Bridgeport, which most of you have as well. But this just kind of evens everything out. Isn't that neat? Enough on that. By the way, coming up are 3 videos that I'm making. 1, how to use a growler. Number 2, how to use a growler for magnetizing and demagnetizing. And number 3, having fun with the growler and showing you how to use it to determine paramagnetic materials and metals, something that not too many people know about. You might find it interesting, so watch for that. But what I want to talk about now is this little micrometer that I bought in that recent video. Okay, in that video, this is ruined, by the way. Now that turns, but notice that the spindle isn't turning. It's frozen up and it isn't worth messing with, although many people want me to try to restore it. But my point was that I said, I can't see a name on this, but there's an MW, so I think it's Montgomery Ward's, but I've never seen Montgomery Ward's actually use that logo. So I did a Google search and again couldn't find anything on that. Then I did a Google search for Moore and Wright and still couldn't find this logo, but several people in the comments said that's a Moore and Wright micrometer from England, and I'm pretty sure they're right, even though I'm not able to prove it by anything that I found on the internet. And by the way, Moore and Wright tools were excellent, probably the equivalent of Brown and Sharpe or Starrett. Too bad that was left out in the backyard. I use these pica fine point markers. I absolutely love them. I still have people asking me where you get them. I believe Amazon and many other places, although this one was given to me a couple years ago, and they last a long time, by Doug Bollinger, and they're just wonderful, but they're not cheap. I think they're $5 or $6, but at Menards you can buy the Dixon Reach, they call it. The only thing is these are child-proof. That is, most adults do not have the strength to open them, so that's annoying. Hopefully, if I would buy another one, they have improved that, but these are just so handy. They call them long reach, fine point. These are just wonderful. Get yourself some. Okay, let's talk about this ammeter here for a minute. And someone mentioned, actually several people, including my buddy Craig, who runs a powerhouse and knows all about high voltage and high amps and all of that, but they all said, I better unplug this, that no way could this be directly hooked up to something that drew 4 amps. You know, you'd blow the thing apart. So a transformer is required, and I forgot what the ratio is, but something like 10 to 1 or, you know, like that. So I'm going to run some power tools here just to show you what I mean, and I can check the amperage with them. But, you know, even though these 2 studs here are pretty good size, visualize putting 400 amps from an arc welder through here. Naturally, you'd blow it up. So I made some test leads here, wasted a half hour doing that, so it's in series. And watch the needle now. And all I'm going to do is run this a little electric drill, which draws about between 1 and 2 amps, according to the nameplate on here. Now there's always an initial starting draw on any motor that exceeds what the regular running amperage is. So let's take a look at this. Okay, it'll come up to about 300, which actually is 3 amps. So watch this. And then it'll back down to about the 100, which is 1 amp. Just a little bit over 1 amp. Actually, it came up to what? I'm thinking of another drill. About 2.5 amps when you start it. No, it did go all the way up. Okay, interesting. Okay, the amp probe is on there, so watch the digital read. It should be between 1 and 2. It's reading 2 amps, but backing down to 1, so it's probably between 1 and 2. I don't know if I can set the decimal point on this or not, but I'm just proofing it here with another type of meter. This soldering iron reads what, 2.5 amps. Look at that little beauty. You can see how often I use this. Watch the meter. So it goes up to, really it's only going up to about, what, 1.5 amps or so. And it actually is 2 speed. 2 speed, 2 heats. And the amp probe is reading 2. I don't know if you can see that. Alright, that's enough on this. I just wanted to tell you that it had to be used in conjunction with a transformer of some kind, which I do not have, nor do I care. What was George Westinghouse most famous for? Actually, 2 things that come to my mind besides the thousands of things that he did. I'll tell you in a minute. Well, if you watched the original video a week ago, you watched me buy this box of 6 decrepit dial calipers. Well, somebody just left a comment and he said, these are just perfect. Don't even bother doing anything to them. Sacrifice them and use them for your scribing purposes, such as this. You see a lot of people doing that, and we don't recommend doing it with your good caliper because sooner or later you're going to wear the points. But these would be just perfect for scribing as such, wouldn't they? Clean them up a little bit and make sure they zero out. And you know, this is a mitutoyo. That would cost $100 if a fella had to buy it. All right, that concludes this 5-minute video that turned out to be 20 minutes. Thanks for watching. Be sure and watch my, well, 1,300 other videos. This is Mr. Pete saying so long for now. Hope you liked the video. Oh, one last thing. To me, George Westinghouse was most famous for inventing the air brake for the railroads, and secondly, he is the one that insisted that we use alternating current rather than Edison's direct current. And they had a battle, Edison and Westinghouse, over which is better, and of course, alternating current prevails. So long for now, this is Mr. Pete.